From the outside, you can't tell what is inside a black hole. You
Whose mass and energy are both at 27 manifestations of the same field, a somewhat unfamiliar conception for physicists.
Today we'll discuss one of the most researched topic in the field of science, black hole. Let's start and take dive into a black hole. A black hole is a region of space-time where gravity is so strong that nothing, including light and other electromagnetic waves, has enough energy to escape it. The theory of general relativity predicts that a sufficiently compact mass can deform space-time to perform a black hole. The boundary of no escape is called the event horizon. Although it has a great effect on the fate and circumstances of an object crossing it, it has no locally detectable features according to general relativity. In many ways, a black hole acts like an ideal body as it reflects no light. Let's talk about formation of black holes. Gravitational collapse occurs when an object's internal pressure is insufficient to resist the object's own gravity. For stars, this usually occurs either because a star has too little fuel left to maintain its temperature, because a star that would have been stable receives extra matter in a way that does not raise its core temperature. In either case, the star's temperature is no longer high enough to prevent it from collapsing under its own weight. No known mechanism is powerful enough to stop implosion, and the objects will inevitably collapse to form a black hole. History of black hole. The idea of a body so big that even light could not escape was briefly proposed by English astronomical pioneer John Michael in a letter published in 1974. Michael's simplistic calculation assumed such a body might have the same density as the Sun and concluded that one would form when a star's diameter exceeds the Sun's by a factor of 500 and its surface escape velocity exceeds the usual speed of light. Michael referred to these bodies as dark stars. He correctly noted that such supermassive but non-radiating body might be detectable through their gravitational effects on nearby visible bodies. In 1931, Subramaniam Chandrasekhar calculated using special relativity that a non-rotating body of electron degenerate matter above a certain limiting mass, now called the Chandrasekhar limit at 1.4 m, has no stable solution. Oppenheimer and his co-authors interpreted the singularity at the boundary of the Schwarzschild radius as indicating that this was the boundary of a bubble, means black hole in which time stopped. This is a valid point of view for external observers, but not in falling. An outsider observer would see the surface of the star frozen in time at the instant where its collapse takes it to the Schwarzschild radius. Also in 1939, Einstein would attempt to prove the black holes were impossible in his publication on a stationary system with spherical symmetry consisting of many gravitational masses, using his theory of general relativity to defend his argument. Months later, Oppenheimer and his student Hartland Cinder would provide the Oppenheimer-Cinder model in their paper on continued gravitational contraction, which predicted the existence of black holes. In the paper, which made no reference to Einstein's recent publication, Oppenheimer and Cinder used Einstein's own theory of general relativity to show the conditions on how a black hole could develop for the first time in contemporary physics. On 12 May 2022, the ETH Event Horizon Telescope released the first image of the Sagittarius A star, the supermassive black hole at the center of the Milky Way galaxy. The published image displays the same ring-like structure. The brightening of this material in the bottom half of the processed ETH image is thought to be caused by Doppler beaming. Black hole terms explanations. Let's talk about the terms which are used in the black hole. The first one is event horizon. Far away from the black hole, a particle can move in any direction, as illustrated the set of arrows. It is restricted only by the speed of light. Closer to the black hole, space-time starts to deform. There are more parts going towards the black hole than parts moving away. Inside the event horizon, all parts bring the particle closer to the center of black hole. It is no longer possible for the particle to escape. The defining feature of a black hole is the appearance of an event horizon, a boundary in a space-time through which matter and light can pass only inward toward the mass of the black hole. Second term is singularity. At the center of the black hole, as described by general relativity, may lie a gravitational singularity, a region where the space-time curvature becomes infinite. Photon sphere. The photon sphere is a spherical boundary of zero thickness in which photons can move on tangent to that sphere would be trapped in a circular orbit about the black hole. Thanks for watching this video. Hope you like this video. Like this video, subscribe this video and share to our friends and family. Thanks for watching.